Alright, Assalamualaikum everyone. So today's class, our focus is on practical lab number 3. So in this practical lab, we'll be doing some exercises which involves torque calculation, and we will be concentrating on something called lead screw. So if you go to VLE, you can search for this section, which is practical 3, 8%. So you have one PowerPoint file, you've got a CAD file in a folder, another CAD file in a folder, and then there are a bunch of other files. One of them is Excel file for calculating lead screw, torque and such. Another one is some guideline on how to select lead screw, and then some photos, and then the submission. So let's look at the overall picture. So this is what we'll be doing today. So everybody's okay? Have everybody downloaded this one? I'll give you a few moments to download the actual file, because later on we'll be doing some assembly first, and then we'll learn some theory on how lead screw works. Okay, so let's go through. For today's work, we are going to be assembling this something called a vice grip. So this one is something that you can see in the workshop. So in the workshop you can see something like this. It is some sort of a vice. So this vice has a clamping grip, and in order for this vice to travel forward and backwards and giving it the clamping force, you need to rotate the clamp using a lead screw. So you can assemble this one later on, and then we are going to use something called lead screw. We're going to use which one? We're going to try this one. Mechanical made something called screw. We are going to assign it to rotate at to travel at 4 millimeter per revolution. So meaning if you rotate the handle for 360, you are going to get a travel of 4 millimeter. So this is the first portion of it lah. But before we do this, we'll go through some theoretical parts. I might as well do this later. You need to also select suitable lead screw properties. For example, we want to ensure a minimum clamping force of 800 kilogram force. So how to select this one? So this one, later on you will look at some Excel file, and you can also look at certain formulas to calculate this. Maybe this one we'll do later after we have assembled everything. Then you guys can really see what this is all about. So yeah, 2 parts lah for this today's practical. So slightly more work for us to do, because I believe Monday is a Merdeka holiday. So you guys can continue to do the second part. But we'll do the second part also by today. Okay, so before we go on more on theoretical parts, I think it's a good idea for us to assemble this one first on your own. Okay. Let's everybody open up your SolidWorks. And definitely you guys have to download lah this file. Let's do this one first, which is Vice. If you look under VLE, under Vice cat file, it's kind of a lot lah. Let's assemble first, then we will learn the theoretical parts behind lead screw or lead screw. Lead screw, how's it pronounced? Lead screw. Lead screw or lead screw. So some of you will be using lead screw for your final year projects. So I need you guys to understand how to calculate the motion, how to calculate the diameter, what kind of force you can give to lead screws. So this is the one that we'll be learning today lah. For automation, you can see a lot of lead screw being used lah. It is easy. Why? Because you are converting rotary motion into linear motion. So this is what we'll be doing. So download the Vice folder in your VLE. This one. Download the whole folder. And then you need to assemble it properly. Macam ni lah. Assemble like this photo that you can see here. I believe I have downloaded everything. So this one, right click, extract. So this is the one lah. So this is my file. So I'm gonna go file, and then I'm gonna create a new one, and it's going to be an assembly. Click on OK. Semua orang buat sama Everybody have to do it on your own. It's great now if you can learn using 2 screens. Then you can work while being in this virtual class. So browse for parts. So the parts that we are looking for is somewhere in desktop. It should be Vice cat file. So I've got a number of ada 6 lah. So I have 6 parts over here. So I'm gonna drag everything lah. Select all. Click on open. So I'm gonna just put everything nearby. This one, and then finally one more, I think. Oh, one more. Yeah, I've got it all. So I've got 6. So obviously I need this part to be the base, some sort of like a fixed part. So this one, free sliding jaw, I need to make it float, and then the free base will be considered fixed, because in reality also, right, this one you have to fix it to a table or something. So now you need to assemble all these parts according to this photo lah. Assemble this one. If you see clearly, the clamping plate, kita ada 2 sini. So you've got 1 clamping plate. You've got the same thing over here. So you got 2 clamping plates. So this jaw here, you have this thing moving in this direction. So you got this lead screw. So this is actually a lead screw. And then you've got this handle. So this handle is the one that is giving the torque for you to clamp things, right? Cuba buat ni dulu, everybody. I'm going to time you guys maybe around 5 minutes. Okay. Put this aside. Where is my SolidWorks? Okay. Meanwhile, while you are doing the assembly, I will also do the same thing lah. Bring certain parts. This one, I can rotate this thing like this. So one of the best way for me to assemble something with a hole, something with a screw hole, is just to click on mate and choose concentric lah. This screw hole to this circle. Okay, and then this screw hole to this hole concentric, and then I'm going to coincident this surface with this surface. Okay, that one is okay. And then this slider, remember you can rotate, right, using right click. If you use left click, it will pan the object, so your object is pan. If you use right click, dia akan jadi rotate. So you've got a slot here. It is supposed to sit somewhere here. So I might as well create a parallel surface first. Mate, parallel the bottom surface with this one. So this one is parallel, but this one can still rotate. I think I have to concentric this cylindrical hole to this cylindrical hole. Are we okay now? So yeah, we are okay now. So I only need two. I only need two because I need this to be moving. If I constrain 3, it will not be moving at all. So obviously this plate I need to duplicate. So click on this plate, free jaw plate, right? And then click Control. You can drag it out. So you can duplicate part easily by doing that. By right, this thing needs to rotate, right? Because you can see here, this is the countersunk hole. It should be on the outside lah, because you are screwing it inside here. Again, you have screws. Kita pakai ni lah, mate and concentric, cylinder hole to this cylinder hole, and then accept another cylinder hole to this cylindrical surface, and then I'm going to coincident this surface to this surface. So I've got a slider moving on this vise. Okay, so hopefully you guys are progressing same as me. So let's finish this today. You don't have to come to this work again. Our class is long. Our class is about 3 hours. You guys should be comfortable doing all this. So obviously, if you look at the photo, I have this main lead screw. So this lead screw needs to be assembled to the slider. Okay. Let's take the main shaft. I can rotate the shaft. Now I can assemble the shaft mate. Concentric. This circle to this circle. Is it supposed to go all the way in? I guess so. It should be like that. So if it is supposed to go all the way in, I need to mate this top surface with this surface, and then click on OK. So make sure your lead screw still can be rotated. So like that lah. So it goes like that. What else? Let's put this shaft inside here. Choose concentric. This circle, put inside here. You can lock it. I think you do. Let's say if you want to lock, just click on lock lah. Tekan sini. Lock. Oh no, it will not go there. Concentric lah better. Lock rotation it is. I think lock rotation. Choose lock rotation. I think no, it can still move Never mind lah. But it cannot move that way Okay, so now let's take this globe. What this? Okay, you need to two of this part Click of the item, click Control, drag. Click on the item, Control, drag. You will have two parts. Okay, let's put this there. Mate cylindrical surface to cylindrical surface. Okay, but this thing can still move. Never mind. Concentric. This to this. Mate coincident. Can you choose this surface coincident to this one? Yeah, you can. Okay, and the last one, coincident this line to this line. I guess we're okay now. This is what I want you guys to do lah. Can you rotate this now? Boleh kan nak rotate benda ni? Or cannot? Can. You can rotate, but this thing will slide out So what you do is you can lock. Tekan mate. Tekan lock. Lock apa dia? This one to this one. Boleh lah. Cuba rotate tengok. Dia dah tak gerak kan? Dia dah tak gerak. So you can choose lock. Okay. So at least you guys should have something like this. Siapa nak tunjuk? What have you done? Teng tereng. Raja Kamil Ashraf. Macam mana? Can you show your screen? Teng. Siapa dia nak buka screen masing-masing? Anybody completed already? At least you should have something like this, okay? And the next thing you do is you have to answer certain questions lah. Number one is this one. You need to set this one. Lead screw rotates at 4 millimeter for every revolution. So let's check it out. Macam mana kamu nak calculate? Kamu nak bagi duduk hujung sekali. Boleh tak? How do you do this? You can choose move component and then select collision detection and then you drag it. Kenapa tak berhenti Patutnya collision detection ni dia akan accept dulu kot lah. Move component, free drag, change to collision detection. Okay, dia ada warna biru tu lah. It has some sort of yellow color, blue color lah, but it will not stop So change to this one, physical dynamics. It will automatically stop when it detects motion. Kalau kamu tak tekan physical dynamics, it will move right, it will penetrate with other bodies. So you choose this one, physical dynamics. Okay. So right now I can see a gap. How much is my gap?
Sir, physical dynamic tu untuk apa? Kita bahas kan?
Physical dynamic, dah. So kalau kamu buat standard drag, kamu tarik-tarik dia boleh what do we call? Interfere with each other. So this is not correct, right? So this is not good. It will interfere. So kalau kamu tekan move component, tukar ni physical dynamics. The moment you touch an object, it will stop. It will not move any further. So sekarang barulah kamu boleh kira berapa gap. Cuba kira. Macam mana nak kira gap? How do you measure distance in SolidWorks? Anybody know?
Evaluate.
Ya betul, evaluate kan. Evaluate, tekan, measure, sini ke sini. So distance saya adalah, saya tulis kat situ kan, nampak 83 mm. So kalau 83 mm, mari kita buka PowerPoint sikit. So I have a gap of, ini kan 83 mm. Kalau saya punya lead screw rotates at 4 mm per revolution, so berapa revolution baru kita boleh clamp all the way jadi 0? Berapa? 83 divide by 4. Tekan calculator. Teng teng. 83 bahagi 4.
20.75 saja.
Alright. So kita punya lead screw akan rotate by 20.75 revolution. Okay, so this is the data that we have lah. Okay, cuba tengok. Sekarang kita akan letak lead screw punya mate tu. Lead screw punya relationship. So let's go to assembly, tekan mate. Pilih something called, I think it's mechanical mates. It should be this one, screw. Cuba tekan screw mate. Dan hampa buat sendiri. Cuba buat sendiri tengok. Screw. Very easy here. Revolutions per millimeter. Ke distance per revolution? Which one will it be? Yes, I can hear you. 4 mm, 4 mm distance per revolution. So cara dia macam mana? Pilih je lah kan. Nak pilih kat mana? Which one should you choose? Dia suruh pilih mate tau. Mate selection. So which mate that you should choose? It should be the mate which has this value lah. Let's try this one. It's gotta be one more, right? This has to be interacting with this circular surface. Boleh lah. Jadi dah, senang je. Right? So make sure you guys know how to do this. But obviously, I have some problem. I cannot clamp all the way. So what do I do now? How do I know this is 4 mm? Try rotate satu rotation. Alamak. Teruk ya. Move component. Tekan physical dynamics. Bring dia sampai ujung. Sampai ujung So this is all the way to the end. How do I rotate this 360 Pegang handle ni. Alamak, teruknya. It's too sensitive One rotation is 4 mm. Gila kot tu. So I'm gonna try. Okay, one rotation. Evaluate. Measure this surface, this line to this line. 1.48 saja. 4 mm per revolution. Can already see ni kena buat motion analysis baru nampak. Okay, let's solve step by step. Number 1, I need to redesign my clamping device. I do not have enough lead screw punya panjang. The lead screw is too short. Now you need to modify something so that this thing can clamp all the way. At least it should be able to clamp 1 mm plate. 1 mm plate thickness. Meaning you need to design up to 0 lah. Kena make sure dia sampai macam tu. Tang. Right? There's something wrong here, right? So what should you do? How long should you enlarge? Bukan enlarge What part should you modify? Is everybody up to speed with this? Do you know how to modify certain parts? If that part is problematic, obviously I need to modify certain things. But then again, what should I modify? That's the thing lah. Macam mana nak buat? Siapa nak tunjuk dia punya skrin ni? Ahmad Hafizuddin. Cuba buka skrin kamu. Cuba modify tengok. Oh, Hafizuddin. Macam mana? Everybody? Obviously, you need to modify this one. Free vice screw. This part. So, click on this part. Right click. Ni, go dekat atas. Open part. But before you open part, obviously the modification that you need to do is you need to make sure this thing is longer, right? So elongate the part. But how long? Choose evaluate, tekan measure this surface to this surface. The distance is about 42 mm. So you need to modify at least adding about 42 mm lah. So go to the part, right click, open part. So this is the part. The part is extruded. What can you modify here? It is like that. How do you modify? It doesn't have any. It doesn't have a lot of model 3 here. Ini dia extrude lubang ni je. Macam nak buat? So no choice lah. This one. This one no choice. You have to extrude. Go here. Sketch. Control 8. Convert entities. Tekan bulat ni. This one. This one. And then exit sketch. Extrude. By let's say 45 mm. 45 mm. So you have to create the same hole again lah. Maybe go to front plane. This thing, right? You have to make it shift it. Maybe
Ubah extrude dia.
8 mm. Apa?
Ha? Tak cuma tarik extrude dia, cuma tarik extrude dia ke atas.
Yeah, you have to shift this hole to the left hand side lah. Or maybe there's a better way to modify this Extrude ni pun boleh tak boleh, ni lubang.
Tak, maksud saya buka daripada sketch je. Tak boleh.
Shift sketch ni boleh kot.
Tak boleh saya sebab dia punya bawah.
-20.
Dia punya tu ada kat bawah. Tak boleh.
Tak boleh. Cannot roll back bar. Tapi ni basic je kan. Hampa boleh buat kan? Can you guys do this?
Boleh saya.
Senang je ni. 20 35 50 too much extrude cut. This should be through all both sides. Tekan OK. Okay, so something like this lah. So now you go back to window, pergi balik assembly 1. Models have been changed. Tekan yes. So ada something yang akan problematic lah, especially this one. This made jaw handle rod ni kan. Ini yang tak okay ni kena delete lah. Benda-benda yang tak okay. This one delete. Yes. You need to assemble again lah the shaft at the end. But the thing is, never mind, we'll do it slowly. Get back that particular part, insert the component, browse, shaft ni, free handle rod ni. We'll mate it back. Definitely concentric. Letak dalam lubang ni. And then accept. I'm gonna make.
Hasil
Aha.
panjang dia kita tambah berapa lagi?
Itu kamu sepatutnya kena evaluate sendiri. Kamu evaluate berapa kena tambah. You have to use the function called evaluate. And then you have to measure on your own. You are solving problems. This thing goes here already. Okay, I have to use something called, I think, lock. Made lock. Menatang ni and this shaft. And then they're gonna be fine. Yeah, they're fine already. This thing I can put it here. I have to do this again lah. Cannot be lazy. Circle, circle. Circle and circle. And then coincident this edge to this edge. Coincident this edge to this edge. Okay. Dia kena pula tu So mate saya yang lock tu kena edit feature kejap. Lock, delete dulu. Keluarkan dia sekejap. Take it out. Can this rotate? Yeah, it can rotate. Okay, I'll lock again. Nampak boleh buat kerja ke? Dengar membebel macam ni. Ha, like that. So, this is the final test. Move component, tekan physical dynamics, tarik sampai ujung. Alamak slownya. Oh, kalau physical dynamics jadi betul-betul real lah. Aduh. Aduh lah. It's very slow. And then it's resets lah. Okay, sekarang dia reset. Saya tak boleh gerak dah. Sebab apa? I'm using physical dynamics. So now, if you still remember, let's now we calculated kan. Dia kena rotate berapa kali entah? 27.83 bahagi 4. 20.75 kali baru dia akan climb sampai habis kan. So that's the thing lah. So if you want to do some motion analysis, of course, go to SolidWorks add-ins, tekan motion dulu. And then cuba letak motor. And tell the thing to rotate by 20 revolution. Tengok dia sampai tak sampai ujung. So SolidWorks add-in has been done. What is keeping it slow? I don't see window tools. Window 3D view, SolidWorks motion. Mana saya punya SolidWorks motion ni? Sudah klik. Low simulation ada, window, edit, view display, toolbar, workspace default, SolidWorks motion pula. Never mind, save it first. Save as your part. Desktop, Vice. Don't forget, right? Save your file. Where is my Oh no, not this one. I think I need to close first because I cannot find my SolidWorks motion here. Let me try to open this again. Assembly. Editing assembly. Model 3 views. Tak ada pun. Have you guys completed? Viewports, tools. Should be under here. Workspace. Motion manager. Brother, motion study. Motion manager. If you lost this motion thing, go to view, pergi dekat user interface, and then tekan ni motion manager if you lost it. Okay, so I'm going to try. Ini dari ujung lah kan. So I'm gonna try to put a motor and tell the motor to rotate by 20.75 times. So choose one motor, put here. Here is fine. Constant speed dia jadi distance no? Distance oscillating. No, segment data point. It should be distance. So degrees So 20.75 kali 360 degrees. 7470. For how long? 5 seconds. Never mind. So I can ask it to rotate lah. 20.75 times. Patutnya dia sampai ujung. Tak sampai lagi. Kenapa dia tak sampai? Edit feature 74750. If that is wrong, maybe there is something wrong with screw. Edit feature. Ni. Edit feature ni saya letak 1 kan? Kita letak 4. Tekan accept. And then I can calculate again. Ya. Dia akan betul-betul jumpa dekat kamu punya clamping surface lah if you calculate it properly. So this is the thing that you should do lah for this particular part. Semua orang patut dapat macam ni lah. Apply a motor 7470 degrees. Kalau whatever the thing you have, radians or whatsoever, put in lah berapa radian untuk dia rotate by 20.75 times. If I play again from the beginning, so it will give you exactly what it is supposed to happen lah. So this is one relationship. End of part 1 lah. Part not yet ending. Kita belum masuk lagi teori. Boleh ke hampa?
Boleh, sir.
Boleh. Okay, so let's learn some theoretical part. So you've learned how to model this thing. Let's learn some theoretical parts. So you've done, ini dah siap, ini you've done it also, and then you've modified it. So once you have designed it properly, we need to show lead screw punya properties. So you need to determine a lead screw properties for a vice clamp to ensure a minimum clamping force of 800 kg force. Kalau 800 kg nak clamp kan, maksudnya this way, this is the clamping force, 800 kilo. What is the corresponding torque applied? In order to understand this, you need to understand lead screw first. So cuba tengok ni, teori ni. Kamu akan dapat banyak idea lagi if you visit this website lah, linearmotiontips.com ni. You can click on the URL link there and get some ideas. So yang paling penting when you have a lead screw, kita boleh kira berapa dia gerak. So berapa dia gerak adalah called lead. So just now kan kita dah kira kan dia punya gap adalah 83 mm. So in order for this 83 mm, kita perlu berapa tadi? I think 20.75 rotation. Since it is moving at 4 mm per revolution. So kalau dia cakap 4 mm per revolution, meaning kita punya pitch ni adalah 4 mm. So this is very important when you are buying lead screw. Pitch dia. Pitch ni maksudnya dia duduk kat sini kan. Lepas tu dia akan turun bawah. Tak nampak macam ni lah. I need to draw again. So lead screw let me prop up a I think I have already here. So lead screw, kadang-kadang bila kamu beli lead screw, dia ada single lead. Ini single lead. Maksudnya dia ada satu je lead dia. Kadang-kadang dia ada 2 lead. Kadang-kadang dia ada 3 lead. Kadang-kadang dia ada 4 lead. So you cannot be confused. Kalau kamu beli double lead kan, kamu akan nampak pitch dia lagi dekat. Lagi dekat, lagi dekat, lagi dekat. Kalau single lead, kamu akan nampak pitch dia macam jarang sikit. Kalau triple lead lagi dekat lah, kamu nampak ini lagi lah dekat nampak. So why do they put quad lead dengan triple lead ni? Because triple lead, double lead dengan quad lead ni dia akan take a lot more torque. So kalau saya letak satu screen, if I put another screen here, white screen. So let's say ini kamu punya, how do I change color? Cannot. Ini kamu punya shaft kan. So your lead travels like here and then goes here. Macam tu. Ini adalah single lead. Meaning, kalau kamu duduk sini kan, you are here. Kamu nak pergi ke sini, kamu kena turun bawah kan? Turun bawah, 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 bawah. Lepas tu naik atas sampai sini. Sampailah kamu kat sini kan? You are here. So you need to go 1 rotation. You will travel by 1 pitch. 1 rotation by 1 pitch. Macam mana saya nak tukar color ni? Pointer, color. Nak kena tutup ni pula no. I have to change color. Then this thing goes. Ni nampak ni. Okay. If you have one lead, this is you. Kamu jumpa kat sini. Ini adalah satu lead. Kadang-kadang dia tambah lagi satu lead. Ini lead orang lain ni. Ini orang lain punya. Ini color dia merah kan. Ini dia jumpa kat sini actually. Ini biru punya. Biru ni dia pergi kat sini. So, if you look carefully, bila kamu nak kira pitch ni, lead ataupun pitch, kamu jangan kira macam ni pula. Ni, habis lah ni. Kira ni habis. Silap beli lah. So, looks can be confusing sometimes. Kalau kamu kira macam ni pula, lagi salah lah macam ni. This is wrong already. Kamu kena tengok original dia tu. So, kalau nak tengok dia macam mana, kamu kena potong. Kalau kamu potong kamu punya lead screw ni, kamu akan nampak ni. Ini adalah double. Ini adalah triple. And this one is quad. Ada 4. So, be careful lah this one. Later on, if you buy anything, when you want to calculate pitch and lead, and berapa dia boleh travel, you need to take care of this lah. Because certain lead screw, you have more than one threads. Okay. So, formula dia straightforward lah. Ini. L is equal to number of threads kali dengan pitch. Next thing. Okay. So, let's say we have a lead screw here. This is some theory that you should, let's baca it a bit. So, when a screw thread is very steep and has a large lead angles, the torque required to push along the screw can be large. Apakah lead angle? So, lead angle is this one. The keserongan dia tu. The lead angle. So, this one is denoted as this one lah, lambda. This is something called lead angle. Typical lead angle is about 2 degrees to 6 degrees. Small lead angles menyebabkan skru tu tidak akan turun sendiri. Kadang-kadang kamu pakai lead screw kan. Kalau angle kamu besar sangat, kamu pusing naik atas, lepas tu dia akan turun sendiri. Dia akan slide down sendiri. So, if you have a very big lead angle lah. So, you have frictional forces on the threads yang menyebabkan kita punya lead tu akan lock. So, kadang-kadang we need this property lah. For example, kalau kamu ada car jack, kita nak bila kita pusing kan, tok, kita release, dia tidak akan turun. That is very important also lah. Kalau kamu punya lead screw, dia punya angle too big and too much lubricated, bila kamu remove saja torque, dia akan turun balik due to the compressive force. Nanti you'll see this one when we do the next part lah, which is car jack. So mathematically, kalau kita nak buat dia self-locking, ini adalah coefficient of friction. Mu is the coefficient of friction at the nut to thread interface. Ini kena lagi besar daripada tangent of ni 6 degrees punya ni, lead angle. So typically, if you are lubricating the surfaces, roughly is about 0.2, 0.15. Jarang lah 0.1 ni. 0.2 lah roughly. So, you can also calculate berapakah force untuk kita angkat load. Untuk kita turunkan load is a slightly different formula lah. So, how do we come about to get this formula? We can derive using angled surface. Kita ada This one is the torque rotating. Ini adalah normal force. Ini frictional force. Ini load kita lah. Ini untuk, ya, this is the load which is given at the lead screw. Torque is equal to force times radius. So basically, you guys need to be comfortable using the formula lah. If you can derive, it's very good lah. But at least you can understand how it is being derived using this free body diagram on inclined surface. Kan, skru ni, kamu nampak dia panjang kan? Walaupun dia panjang dan dia helical kah? Helical surface kan? Kalau kamu ambil pisau, macam mana? Analogy dia lebih kurang kamu tahu tak buah apple? This is a buah apple. Kalau kamu kupas apple ni, kupas apple, kamu akan dapat satu panjang kan? Kulit apple yang panjang. Betul ya? So, what if you do the same thing to this screw? Cuba kamu kupas screw ni. Kupas ya. Kupas. Kamu akan dapat ni, panjang ni. Very long surface like this. So inilah yang derive tu. This one nampak je pendek kan? This looks short. But the analogy is something very long lah. Bila kamu kupas skru ni. So this is what something called a wedge. If you still remember. Wedge. Okay. So you can use this formula to calculate force to raise the load. Naik atas. Ini untuk lowering the load. Apa yang pelik kat sini? Semua benda ada tulis kat sini lah. Load is our... Actually, you can open up lah. This Excel I have supplied in the VLE. You can open it up. Maybe we can open it up now. Let's see. Discard. Let's go to your VLE and then tekan the current thing that we're doing right now. This one, tekan ni. Lead screw calculator. Press on lead screw calculator. XLS ni. Ini untuk metric screw lah. Open it up. So, formula yang kita belajar tadi kan, this formula is embedded and coded in the formula for this one lah. You can turn on enable editing. So, let's look at this. Yeah, for example, major diameter of the lead screw. Berapa kita punya major diameter sini ya? Again, tekan evaluate, tekan measure, tekan je ni. Tik. Diameter dia 13.8. So 14 lah. Pitch dia berapa tadi? 4 lah kan? Pitch dia ada 3 je ada sini lah. I don't have more. Maksudnya kalau lah kamu tukar 16 kan? 16 pun dia 3 je. 22 ada 5. Ya. So tengok jugalah. Kadang-kadang what you design tak ada standard dia. This one is for ISO lah. Kalau kamu pilih lead screw, Sekejap. Ni diameter kan? Yang tadi saya measure apa? Diameter lah. Kalau saya pilih 16. Pitch 3 ni. Kalau 16 inch. Bukan. 16 mm. Kita cuma ada pitch 3 je. Kalau saya rasa 22 kot. 22 ada. 20 tak ada. 24 pun ada sampai 5. 22 dah ada sampai 5 lah. Never mind lah. Explore this one. Just the lowest that we have 13. So load. This is the load that you apply lah. For example, force ni berapa? 800 kilo. 800 kali 9.81 7848. Katalah kamu bagi load ini 7848. Coefficient of friction. Ini saya letak 0.1 kan? Ni dia dah cakap tu. Certain things that you have. I think just now we have reviewed. It's about 0.2. Thread angle 2 alpha 30. Ini 2 alpha ni. This one kena tengok lah. Thread angle, that one that you have in the thread angle is 2 to 16. Lead angle, included angle. Okay. Thread angle ni kena tengok data kita dekat kita punya lead screw. Never mind, just use this 130. Number of thread starts 1. Mean diameter of lead screw 12.5. Lead 1 is 3. Torque to raise the load Newton millimeter. This is the torque required lah. So you can use this calculator. Kalau tak mau guna calculator ni, you can punch in using this formula. Force to raise the load and force to lower the load. So these things is taken from your, I think, machine component design punya handbook. If you remember, there's a textbook called Shigley. So a lot of components, you can find the calculation here lah. Shigley, this one. So what else? Itu untuk calculate torque lah. Patutnya kita calculate torque dulu kan, baru kita design lead screw berapa yang kita nak pakai kan. So later on, if you are required to choose lead screw, you can review this one lah, these notes. So let's look at more lead screw related. This is standard for metric lah. So kadang-kadang kita ada threads like this. Sometimes we have square threads like this. This one for American. Ini unified. So major, just now we are about this one 12. Nominal major diameter 12 mm ada. Just now we are, I think we are around here lah. Apa yang ada dalam practical kamu tu tak relate, tak ada size dengan standard sangat. Sebab this one lah 16 mm diameter, pitch dia 2. Kalau dia cakap pitch dia 2, every rotation kamu akan jalan 2 mm lah pitch. Ini untuk coarse threads. Oh, ini untuk fine threads pula. Kalau fine thread, one rotation is 1.5 mm only lah. This one Okay, so if you had to choose lead screw, you can refer to these notes lah. Another good example is here, the Helix lead screw selection. If you go to your VLE, there are some slides being shared to you. Ini adalah from this manufacturer lah. This is the manufacturer for lead screws. So they will give you guidelines lah, how to select. Selalu macam tu juga. If you want to buy anything from anybody, that particular vendor definitely will have some knowledge lah. That's why kadang-kadang kamu jumpa dia punya field engineer kan. So they will give you things like this lah. Some sort of manual yang kamu kena baca. And you have to make selection lah. Apa benda nak beli kan. So this one is also important. Lead screw, what kind of load? How do I make this full screen lah? Can lah. This one lah. This one is for static load. Kadang-kadang kita ada dynamic load. PV load. Limited by heat build-up or friction. Sometimes you are under tension and sometimes under compression. Thrust load. Side load also. What is the RPM yang lead screw rotating? But how do you fix the end? Is it fixed or a fix and free? You're gonna have to think a lot about this one. Yeah, we have something called critical speed. Macam shaft juga kan? Shaft ada critical speed. Sometimes if you don't design properly, there will be a lot of vibration lah if you're using lead screw. So critical speed punya formula kamu boleh calculate ikut diameter lah. Ini dia punya end fixed. What else is important here? Column strength. Column strength ni berapa kamu tekan dia supaya dia tak collapse. Column strength continued. PV tak banyak sangat lah. So at least you know some things lah. If you are to be choosing some sort of lead screw in your design, this is where you should go. This is what you should do. Other than simulating the motion of the lead screw, other than doing this, selecting a lead screw apa nak pakai, berapa diameter. Kalau kena clamp sampai bertantan, janganlah pilih lead screw diameter kecil pula kan. So learn how to use this Excel thing. Don't use Excel only. At least know how to punch in values from here. Right? From this formula which is available in the textbook. This one. Learn how to apply all this. Habislah for part 1. So that is the first part that you should do. So apa benda the next part. Next part kamu kena buat sendirilah. Since I have demonstrated to you guys how to assemble and then apply lead screw punya benda kan, the next part adalah kamu kena buat sendirilah. We would like to do this. Lebih kurang macam ni. Ini adalah car jack. If you look at your practical punya ni kan, ini adalah car jack lah. Teng, apa benda nak buat ni kata ni? Determine the rate of lift. Tu dia. Macam mana? First part ni hampa kena buat je lah. Buat je kan. Ada soalan tak first part ni? Tak ada soalan ke no? Do I have any question here? Ni ada ni. Ada soalan. So kena buat lah. So do the first part. Second part ni you have to do on your own lah. Okay. Siapa ada soalan boleh tanya Second part, number 1. You guys need to assemble the whole thing lah. Assemble the whole thing. Teng. Assemble. Siap. Dia cakap, determine the rate of lift per rotation of the car jack. Macam mana? Kalau lead screw tu rotating at 8 mm per revolution. Meaning kamu punya jack kan, katalah kamu nak design jack yang alternate tab tak boleh. Alternate tab. Katalah kamu nak buat macam ni kan. Let's say kamu nak design benda Allah ni. Kamu nak jual benda Allah ni. So, kamu nak determine berapa RPM saya nak letak supaya electric jack ni boleh pakai. Berapa RPM. So, you don't want to sell something like this. Katalah dia nak angkat kereta ambil masa 10 minit. Is it logical Maybe logical, maybe too long kot. Maybe kamu tak nak lah bagi bila nak pasang tu 10 minit baru kereta naik. Sebab apa? You have chosen the wrong RPM. So you don't want to do that. So you want to calculate first. So inside your analysis, you can find out. Katalah customer kata, please design for me 3 minit. 3 minit too long kan? 1 minit pun very long. 60 second. Kereta angkat. Kereta jacked. Let's say you want to answer something like this. Let's say you want to give 60 second. User dah boleh change the tire in 60 seconds. So, what is the RPM here? In order to jack the car up. So, you need lah this kind of data. Sebab dia punya relationship dia different. This thing will open up. This thing will go up, right? This thing will go down. It doesn't actually go down, the whole thing goes up. So you need to solve what kind of data it is supposed to be. Oh, apparently I have already here. Determine the torque required by user to lift a weight of 500 kilo if the user is lifting at 1 mm per second. 1 second naik 1 mm. And then lastly, screenshot lah what kind of lead screw properties yang kamu choose for your design. So these are the questions that you have to answer lah. This is the second part. And this part, I think you have to do it on your own. Perhaps I don't have to do it lah, because kita dah banyak kali buat assembly kan. All this assembly is becoming very basic for us. Now try this one. Okay, so for this part, go to your
yang tadi macam mana yang saya nak buat apa tu, screw tu yang nak bagi masuk dia pusing benda.
Tak jalan ni?
Saya tertinggal.
Oh ni? Ni tak jalan?
Benda tu.
Oh, this one okay, I'm gonna show it again. I'm going to go to assembly.
Assembly.
Mate yang saya pakai adalah screw.
Screw.
Saya delete je saya delete. Yes. Now I don't have this mate. Bila saya gerak dia tak putar kan. So choose a mate. Pilih mechanical mates. Pilih screw. So it should be this one lah. Distance revolution. Ini adalah 4. 4. Dekat mate selection, pilih circle. Pilih shaft. This shaft. And this circle. Macam tu je.
Circle.
Yeah. One shaft, one circle. Okay, and then click. And then make sure dia jadi 4 lah. Ini 1 mm kan? 4. And then cuba rotate. If you slide, it will rotate lah. This is the thing. So, itulah. Now you don't have, your this design is not so complicated yet, right? If you have more complicated things, you will see lah the whole system interacting with each other. Tapi betul-betul kamu kena make sure mate kamu semua betul lah. Contohnya kamu buat robotic arm ke kan? You have a lot of gears, you have a lot of lead screw. Bila kamu trigger motor jalan je, the whole mechanism will work. Okay. Ini yang susah sikit. Bila lead screw ni putar, berapa dia naik? It will not be so easy if you calculate it manually lah. Manual calculation ya, ada dekat ni, last page. Ini. How to calculate manually benda-benda Allah macam ni. This is something called what do we call this one? This is called something that translate dan dia rotate. Dia something called, kita panggil general plane motion. Kita tak ambil, kita tak belajar lagi manual lah. Nanti kita belajar general plane motion. I've touched something like this. Benda Allah yang translate, dan dalam keadaan translate tu dia rotate juga. Macam ni lah benda Allah ni. Dia travel dan dia rotate. Contoh macam ni. Dia, benda Allah ni travel kan? Travel. Tapi benda Allah ni rotate juga. Calculation dia kita kena pakai vector analysis lah. Nanti kita belajar dalam kelas lah, how to calculate manually. This is something called general plane motion. It happens when you have a combination, combine, translate, campur, rotate. Macam yang first kita buat tu lah, apa nama, piston tu kan. Lebih kurang macam tu lah. The only thing is, today kamu nak assemble this thing and find out berapa RPM yang sesuai. So, user ni, dia bukan nak 1 mm per rotation, okay? Dia nak kereta jack tu naik atas 1 mm every second. Bukan lead screw tu. Not lead screw. Lead screw tu kamu kena cari sendirilah berapa. Boleh lah? Hampa faham kah? The user will not care lah lead screw ni. The user tu nak ni je. Dia nak 1 mm setiap second kereta tu naik. Okay. So, at least boleh tahan 500 kilo lah. At least. Right? Typical car is about, I think 2 ton kot. 2000 kilo. But you jack only one tire, right? If you jack one tire, it's about 500 kilo lah. You don't jack the whole car up. You will never be able to do that with the normal jack. So let's say 500 kilo. So these are the things that you can solve by learning motion analysis lah. So you guys can design something like this. So you will know what kind of motor you want to buy. Does your motor need some sort of gearbox in order to translate rotation of the motor kepada lead screw tu? By looking at this, I can see there's some sort of gearbox kan dekat benda biru ni. See here, there's a motor here. This one definitely there's got some sort of gearbox lah, to make sure suitable punya RPM lah dekat lead screw tengah ni. Lead screw ni it looks very, they are using square lah, square punya lead screw. Itu je lah. That is what you are supposed to do today and Monday. Monday kan cuti kan. So hari Khamis present boleh lah. Siapa-siapa yang ni present your car jack, see your RPM berapa yang sesuai, explain your analysis. Kita buat apa? We are converting a normal car jack to an electrical car jack. Normal car jack, electrical, normal, motorized. Okay? Boleh lah? Hari next Thursday, show your design, what analysis you've done. Okay? Teng teng. Any questions? Siapa yang tak tahu nak buat apa? You can start assembling the car jack. Okay, what else? Siapa nak share anything? Who wants to show what you've done? You can take the screen and show us what you have done.
Sir. Waktu yang kalau saya pakai yang screw tu, dia jadi.
Ini yang practical 1 ke 2 ni?
1,
okay. Skru kamu jadi macam mana?
Dia tak boleh nak make.
Dia tak boleh nak rotate?
Tak, dia tak boleh nak make.
Kamu kena matekan shaft tu dengan another circular surface lah. Hold on Sekejap. So this is if you look properly, this is the mate that I did. Shaft ni warna orange ni kan, orange, and then this that edge yang circle tu, itu dia yang saya buat. Kamu punya dia tak jadi macam mana? Dia tak boleh nak gerak, dia tak nak putar. That is the only thing that I do. Kamu tunjuklah, tengok ke sana. Ni nak jadi dah ni. Mechanical mate screw. Pilih 4. Okay. Pilih main shaft. Lepas tu zoom dekat yang kuning tu. Tu. Okay, tekan accept. Tick. Okay, kalau saya tengok kan, kamu punya assembly tu dia tak coincident tu. Nampak dia ada masalah tu, dia clash. Dia tak betul-betul coincident. Maksudnya dia punya shaft tu tak betul-betul masuk dalam lubang kuning tu.
Mana dia tak betul-betul fix lah.
Dia tak betul-betul axis dia tu. Axis dia tak betul. Kena alignment sikit ni. Kena assemble properly. Ada alignment issue. Orang lain okey ke?
Thank you, Dek.
Okay. Make sure you can do the first part.